Okay, now we're going to take a look at limits algebraically or analytically by a method called direct substitution. We're actually going to go through a couple of different videos of different ways that you would approach an algebraic method of finding a limit, but the first method you should always try is direct substitution. That literally means that whatever your limit is approaching, if x is approaching some number c, it means that you're going to replace all the x's in your function with that c. So let's do a really easy example. So the first example we're going to try is the limit as x approaches 2 of x squared plus 5. Okay, direct substitution means literally that. Any place where I have an x, I'm going to now put a 2 in. So now I have 2 squared plus 5. 2 squared is 4. 4 plus 5 is 9. So the limit of x squared plus 5 as x approaches 2 is 9. Now, I could check this out graphically and look at my picture, and I would see that as I approach 2 from the left and as I approach 2 from the right, my y value would approach 9. But take my word for it, that's a correct answer. We're going to try another function. We're going to try the limit as x approaches 3 of the quantity x squared minus 9 over x plus 3. Once again, I'm going to substitute every x with a 3, so I will have 3 squared minus 9 all over 3 plus 3. 3 squared is 9, take away 9 is 0, 3 plus 3 is 6, I have 0 divided by 6. Anytime I have 0 in the numerator, my solution is 0. So that limit comes out to 0. Next one I'm going to try it. You're going to moan a little bit. I know you are, because I want the limit as x approaches pi over 6 of 8 times the sine of x. Okay, this is the point where if you don't remember your trig, you need to stop this video, because when we do a substitution, we're going to get 8 times the sine of pi over 6. And if you don't remember what the sine of pi over 6 is, go back and look at my notes for pre-calculus review of trig. Pause the video and come back. Okay, I'm assuming now you've got the answer. The sine at pi over 6 is 1/2. So 8 times 1/2 is 4, and this limit is 4. Okay, let's try a couple of trickier questions. So let's try the limit as x approaches e of the ln of x plus x squared plus 5. So once again, I'm going to replace all my x's with e, so I will have the ln of e plus e squared plus 5. Well, we all remember, of course, that ln of e is 1, and 1 plus 5 is 6, so my final answer is e squared plus 6. That wasn't too bad. Let's try another one. Let's try to find the limit as x approaches 10 of the quantity 3x plus 2 raised to the 2/5 power. Okay, so again, direct substitution gives me 3 times 10 plus 2, all raised to the 2/5 power. 3 times 10, 30 plus 2, 32 to the 2/5 power. Okay, hopefully you remember that when you have a fractional exponent, the top part represents the power that you're taking 32, the squared power, and the bottom part represents the root. So you're really looking for the 5th root of 32 raised to the 2nd power. I don't know about most of you, but I could do the 5th root of 32 in my head. I can't necessarily do 32 squared in my head. And the order you do these, it doesn't really matter. The 5th root of 32 is 2. 2 squared is 4. That means the limit of this function is 4. And one last example, I'm going to take the limit as x goes to 1 of the quantity 3 over x minus 1. Direct substitution gives me 3 over 1 minus 1. 1 minus 1 is 0. I can't do 3 divided by 0. That's correct. You can't do 3 divided by 0. This limit does not exist. Okay, hopefully you've had a quick little run through of what direct substitution looks like. It's the easiest of the algebraic methods, and it's the one you should always try first.